Hello students, again this is lesson 25. This is the practice problems that we have here, and so again make sure that you try these by yourself and then come and watch this video to get caught up on the answers and any insight that I might be able to provide for you. So problem number one, Jada has p pennies and n nickels. They add up to more than 40 cents. She has fewer than 20 coins altogether. Write a system of inequalities. If possible, is it possible that the following combinations of coins work? All right, so let's go through those. So this is what I've got. So it says that write a system of equations that show the pennies and nickels. We know that pennies plus the nickels is fewer than 20, so I got a less than sign there. And it says I has altogether with the pennies and nickels, she has more than 40 cents. So I got a greater than a 40 there. And I got 1 cent for every penny, and then 5 cents per nickel times the number of nickels. So this is what I came up with for the two inequalities. And then B, is it possible that she has the following combination? So you have 15 pennies and 5 nickels. And I said no because it comes up to less than 20. We're supposed to have less than 20 coins, and this comes up to exactly 20 coins. So you're splitting hairs, but if they say you have fewer than 20, that means the most you can have is 19 total coins, so not 20. So 16 and 2, okay, now you're at 18 coins, so you do make the cutoff for the 20 coins. But when you add this up, 16 pennies, 16 cents, 2 nickels is 10 cents. Well, 16 plus 10 is 26, which is not more than 40 cents. So that's out too. 10 pennies and 8 nickels. All right, so what do we got here? So 10 pennies is 10 cents. And 8 nickels, all right, so you got a total of 18 coins, which is less than 20, so that works. 10 cents plus 40 cents, 8 times 5. All right, that gives you 50 cents, and 50 cents is clearly greater than the 40 cents. So this last one is the only one that works. The rest are you're either splitting hairs or it's just way out. Okay. And problem number 2. So this one there's a mistake, and I want to make sure that you get that corrected. You'll notice that they go and talk through here. They got 2.4 miles per hour for swimming and 16.1 miles per hour for bikes. All right. And then they come down here. They got 2.4s plus 16.1b, which makes sense for S for swimming and B for biking. And then they go blah, 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 and then they say, oh, there's an H. Well, there is no H in here, okay? That needs to be a B. So make sure that you fix that in your books. Scratch out the H and make it a B. That way it will line up with what you've got here, all right? And then we go through this thing, okay? So make sure you make that mistake. We have one equation. It's represented right here. Since I'm not sure the graph is right, for example, 10.3 is on the shaded area, okay? So 10.3 is right about boop there, so it's within the shading period. But it's not realistic for an athlete to swim for 10 hours and bike for 3 hours. I'll grant you that. All right, these are possible solutions. It doesn't mean that this is where you can pick solutions from. It doesn't mean it will happen. Okay, so it says they bike more than 20 miles total. So we know that we have to go over 20 miles between swimming and biking. I'm thinking we're going to be bike heavy and swimming light. Okay, so not so much for swimming, but lots of biking. So I would probably think that people would be up more in this area than way over in this area. All right. Write an inequality to represent May's last statement. Okay, so let's go back to here. Now this is what I've got. All right. So what we've got here is the same thing that you have in your book, right? I fixed the B and the H problem, right? So she says she wants to think that triathlon athletes generally train no more than 2 hours a day, all right? So the inequality is the swimming plus the biking has to be less than or equal to 2. All right, that's no more than 2 hours a day. So up to and including, but not over 2. Graph the solution to your inequality. So we got this one, this dashed line, and I got this one I'm going to put like right here. Okay, so the points of interest are 2, 0 and 0, 2. Because if you put in 2 for swimming, then you have 0 for biking. If you put in 0 for swimming, then you got 2 for biking. So we have this nice little 45-degree angle thing going on right here. All right. And determine the possible swimming and biking combinations. Well, it's just this teeny tiny little spot right there. Okay. Let me point it out. This little area right here is the area that, with these two constraints, that's where you're working at. Okay. That little area right there. So that's the solution. So that's the letter for D, or for C. So I'm thinking it could be like in this little area, it looks like about 1/2 hour for swimming and 1.5 hours of biking, and that should put you in right about here. All right. So that should work. Okay. And if you look at that, if you actually put that in through here, all right, 2.4 times 1/2. All right. You're taking the equation that you have up here, and you're now putting in 1/2 comma 1.5. If you put that in, you do come up with greater than 20, right? Which is what they want you to come up with per that top inequality. So here's the possibles. Right. On to number 3. All right, so Elaine is buying bracelets and necklaces. Bracelets are $3, necklaces are $5. She can spend no more than $30. So there's the equation that we got, B for bracelets and for necklaces. They add up to less than $30. She needs at least 7 gift items. Okay. Right inequality represents the number of gift items that Elaine needs. Now she needs to have at least 7 gifts. All right. So this is what I came up with. All right. So she says that inequality represents the number of gift items. I said that B plus N, bracelets plus necklaces, has to be at least, in other words, greater than or equal to 7. On the same coordinate plane, graph the solution. So that's up here. All right. So the blue is the one that's right here, and I'm going to make hash marks with mine. So it's this little line that goes right along in here. All right. So it goes from 0, 7 to 7, 0. All right. There's your Myrtle. 0, 7 there and 7, 0. Those two numbers add up to 7. And I know it's everything to the right. So all that's left for the solutions is this little kind of a sliver of an area right in here. That's all the solutions that are possible that satisfy both of those. All right. So you use the graph to find at least 2 possible combinations of bracelets and necklaces. Well, it kind of looks like 8-1 is in there just barely. And also, if you go here to 7-1, it looks like that could work too. All right. In each case, you do have more than 7 total that you sell. And you do come up with more than, or excuse me, under $30. Okay. But there's not a whole lot of wiggle room in this one. It's a very small little wedge for you to work with. And then D, explain how the graphs show that the combination of 2 bracelets and 5 necklaces meet one constraint but not the other. Well, let's just go to 2, 5. There's 2. There's 2. And let me see if I can get to this other one here. All right. 2, 5. I like this one better. 2, 5 is right there. All right. It's not even close to this constraint. It's up in here. So it could possibly meet one but not the other. And so it's no bueno. No luck. And you can do that graphically, or you could actually put it into your equations. 2 and 5 do make 7, but it's not going to make your requirements on the cost. So you're out of luck there. Moving on to the next page. Number 4. Let's start here with a clean slate. Gardener's buying topsoil and compost to fill his garden. His budget's $70, so which means he can spend up to, including but not over, $70. Topsoil is $1.89. Compost is $4.59 each per cubic foot. Select all the statements that represent that correctly describe the constraints. This is a combination of 7.5 feet of topsoil and 12 feet of compost within the gardener's budget. Right? So this is what you've got for your equations. I think that one goes to this one right here. But if you took 1.89T plus 4.59c. 70. This graph represents the solutions. Well, let's look. All right. So in A, I went through and I said, okay, I'm going to go and take this. And I'm going to take 7.5 cubic feet of topsoil, multiplied by 1.89. Take 12 cubic feet of compost, multiply it by 459. And I come up with $69.26. So yes, that combination works. All right. If the line represents the equation, this graph represents the solutions. Okay. Well, it says this, this represents the solutions. Well, kind of yes, kind of no, but this is an equation. It's just going to be a line. If you want the area here, you have to have an inequality to get an area. So this is kind of like one of those, it's so close you wonder if they didn't make a mistake when they wrote the question. But strictly speaking, this equation does give you a line right along in here, but it's dashed, and so we know that it has to be less than or equal to 70. So kind of yes, kind of no. I'll say no, it doesn't, only because that equal sign is a little bit jacked up. All right, and does it represent the solutions? No, this is the solutions that you have, right? So the graph looks good. The graph looks good. It's just that I don't know if they have a typo here or what's going on. All right, I'd rather see a less than sign. Then I know, yep, perfect. And then they got to this one, and so this is screwed up because this says that what you're spending has to be over $70, which means that you have to spend at bare minimum $70, and it's going to be all the stuff over here. Well, that's not what they're asking for. They want to have a budget of $70, which means that you have to spend no more than $70. So this little sign here is backwards. It should be less than or equal to, right? And the delta, the combination of 5 cubic feet of topsoil and 20 cubic feet of compost is within the budget. Absolutely not. This comes up to well over $101.25. So you've really destroyed the budget on that one. All right. Oh, look at this one. This looks lovely. Less than or equal to, just like that one right there. So I like E as well. That looks good. And then you come down here. It says if the line represents the equation, this graph represents the solution. Here it needs an inequality. Yeah. So does this represent the budget constraint? And again, I'm not sure where they're going with this one. B and F look a lot of almost exactly the same, and I'm not exactly sure what's going on there. So I don't know. They just put it in twice and had a typing error or something. I don't know. All right, because this is what I've got over here, and so the line represents the equation, represents the solutions. The line represents this. This graph represents the solutions. I'm not sure why they have practically the same thing. As far as I'm concerned, it looks like the exact same thing. Straight line here. Patched line here. Between the two, between this one and this one, I'd say this one is more correct. All right, so if you circle F as being correct and say that B is not because of the dashed line, I'm okay with that. All right, I'm not sure why they dumped in this thing right here. It doesn't make any sense. I don't know what they're trying to or attempting to say. So I like this line. This line works. All right. On to number 5. Prior writes the equation y equals -1/2 x minus 7. Write an equation that has exactly one solution in common with Pria's equation. That's fairly easy. All right. So if we go and look at that, if you have an equation like that, and you want one solution, you just have to come up with something that has a different slope. And there's an infinite number of equations that'll work. You just have to have something that doesn't have a slope of -1/2. It could be +1/2. It could be 1. It could be -1. It could be 8. It could be 16. It could be -54. I don't care. As long as it's not that same slope, you'll get one equation. So I made it simple. All right. I said y equals x. which is really just y equals mx plus b, and the m is 1 and the b is 0. So what do we get? Y equals x. Right? Simple, simple, simple equation. All right? No solutions? Hey, look. It's got the same slope. That way it's parallel, and it goes through, and it's just simply I moved it up one. Went from -7 up to -6. Beep. They're lying right next to each other, and they're parallel because they have the same slope. There, no solutions. And infinite solutions, that means I just simply got to take this thing and multiply it by 2, just kind of rearrange things. But this is the exact same thing as this. So I take my original equation up here. I'm going to multiply by 2, so I'll get 2y minus 1x minus 14, and then I'm just going to add the x to the other side, so I get x plus 2y equals a -14. Bippity boppity boo. It's right on top. It's this exact same equation. So done. On to number 6. Two inequalities are graphed at the same coordinate plane. Which region represents the solutions? You might be a little bit easier to see it right here. All right. You can see where this is tinted, colored in blue, and hashed. So from this point over to here, down, over, up slightly, and then back up. That's all what you have, right? Everything inside here. Another way to view it is like what I've got here. That's the solution. That satisfies both of them. It's shaded and got the hash marks. All right. Number 7. Here's a riddle. Sum of two numbers is less than 10. There you go. Number 1 plus number 2 less than 10. If we subtract the second number, which would be y, from the first, the difference is greater than 3. So here you go. You can have something like this. Right? I start out with x plus y, but they like f and s per their equation. So first plus second less than 10. First minus second, which is the same thing as saying if we subtract the second from the first, we subtract the second from the first, the difference is greater than 3. Write a system of inequalities for the situation. Well, here you go. That's it. And after this, we go on to lesson 26. That is it for the practice problems. Thank you for your time.